Hello my dear children, glad to meet you with an interesting science lesson. Today we are going to learn a very important topic because the theories associated with this lesson are really important even in our day-to-day life also. I am sure that you have joined for the lesson with the writing book, textbook and the pen. Let's get started the lesson now. Our topic is Unit 16, Force and Motion. Force and Motion, that is Unit 16 of your textbook. In this lesson, I will be explaining about the distance and displacement, what is the difference between the distance and displacement, and what is known as the distance and what is known as the displacement. Then scalar quantities and vector quantities. With examples, I will be explaining what the scalar quantities are and what the vector quantities are. Finally, I will be explaining force and various effects of a force. You know that there are different effects of a force. We will be learning about those effects of the force. Right. You can observe there is a diagram given on the screen. Look at the diagram given on the screen carefully. You can observe that there is a car. The car has moved to another position. The car has moved from one position to another within a certain time duration. Within a time of 2 seconds, the car has moved from one position to another. Then we can simply say that the car has moved from one place to another. The car has moved from one place to another. Through that, we can understand what the motion is. The change of position with time of living or non-living objects is known as the motion. The change of position with time of living or non-living objects is known as motion. Now, I think you can understand what the motion is. Right. Look at the pictures given on the screen. You can easily identify the pictures. What is the first picture? Yes, the first picture is a staircase and the second picture is an escalator. Normally we call that lift. Right. Now you can recall an instance where you use a staircase as well as an escalator to go to the top floor of a multi-storied building. Right? I think you have experiences. As you think, which method is the easiest method? Yes, definitely you will answer me, using the escalator is easier than using the staircase. Why? The path of the escalator is shorter and it is linear than the path of the staircase. Right? Through our experiences, we know that going along an escalator is easier, because the path of the escalator is shorter and it is linear than path of the staircase. The path of the staircase is longer than the path of the escalator. Right. Now, the path of the escalator is linear from A to B. The path of the staircase is not linear and longer than the path of the escalator from A to B. My dear children, I wanted you to explain about the distance and displacement. When we think about the motion of the escalator, it is similar to the displacement because the motion of the escalator is linear. But when we think about the motion of the staircase, when we think about the path of the staircase, that is not linear. Right? That is longer than the path of the escalator from A to B. So, we can say that the path of the staircase is the distance and path of the escalator is displacement. Right. Let me explain more about distance and displacement using another example. We will see. You can observe that there is a cyclist. Right? The cyclist has moved from position A to position B through a certain route. Then the total length covered by the cyclist is called as the distance. The total length covered by the cyclist is called as the distance. But when we think about the initial and final positions of the cyclist, that is known as the displacement. Now, I think you all can understand the difference between distance and displacement. When we think about the motion of this cyclist, you can observe that the cyclist has moved through a certain road, or he has moved through a certain route. The total length of the road is known as the distance, but the shortest path or the shortest distance between his initial and final positions is known as the displacement. Right? Once again, you can understand the difference between distance and displacement. Right? Distance is the total length of the path of a motion, what I explained you just now, and the displacement is the linear length between the starting and ending positions of a motion. Right? Once again, let's read them. Distance is the total length of the path of a motion. Displacement is the linear length between the starting and ending positions of a motion. My dear children, when we describe about the distance, we don't want to state the direction because the distance has not a definite direction. We should not indicate the direction when we are describing about the distance. But when we describe about the displacement, we must indicate the direction. There is a reason for that. The reason is the distance has not a definite direction, but the displacement has a definite direction. So, you have to understand that distance is a quantity without a definite direction, but displacement is a quantity with a definite direction. That is why I said you that when we describe the displacement, we have to indicate the definite direction. Understood? Okay, very good. Let us move on to the next one. Scalar quantities and vector quantities. My dear children, when we are learning science, we meet different quantities. As well, we use different quantities in science. According to the presence and absence of definite direction, we can categorize the quantities into two groups as scalar quantities and vector quantities. Right. Now, let us see what are known as scalar quantities and what are known as vector quantities. The quantities with a magnitude but without a definite direction are known as scalar quantities. The quantities with a magnitude but without a definite direction are known as scalar quantities. I think you all can understand simple English. The quantities with both magnitude and definite direction are known as vector quantities. Right? The quantities can be divided into two major groups, vector quantities and scalar quantities. The scalar quantities have got only a magnitude, they do not have a definite direction. But when we think about the vector quantities, they have a magnitude as well as a definite direction. That is very important. Let us see some examples for vector quantities and scalar quantities. My dear children, here are some examples for scalar quantities and vector quantities. Then you can check whether these quantities have got a definite direction or whether they have not got a definite direction. Here are the examples for scalar quantities. Shall we read them? Okay. Distance, speed, mass, temperature, energy, work, volume and area. Then you can understand that the quantities that are given in the first column of the table have got only a magnitude. They haven't got a definite direction. But when we think about the quantities that are given in the second column, they are vector quantities. They should have a definite direction: displacement, velocity, weight, force and acceleration. So, when we are talking about the vector quantities, we have to indicate the direction. That is the difference between vector quantities and scalar quantities. That was new to you. Now, today you learnt that, right? Once again, I am going to explain you about the distance and displacement using another example. Look at the table given on the screen. You are given the distance travelled between several cities in our country, especially from Colombo to Matara, Colombo to Galle, Colombo to Kandy and Colombo to Jaffna. I would like to draw your attention towards the third column of the table. You are given the straight distance between the two cities, right my dear children. You are given the distance to travel between the two cities in the second column, and in the third column you are given the straight distance between the two cities, right. Let us see. From Colombo to Matara, the distance to travel between the two cities is 174 kilometers. But when we think about the straight distance between the two cities is, it has become 133. Now you can observe that the value has decreased. From Colombo to Galle, the distance to travel between the two cities is 128 kilometers. The straight distance is 107 kilometers. From Colombo to Kandy, the distance to travel between the two cities is 137 kilometers and the straight distance is 122 kilometers. Colombo to Jaffna, it is 395 to travel between the two cities, but the straight distance between the two cities is 365. My dear children, you must understand one important thing by looking at the table. The most important thing that you have to understand there is the straight distance between the two cities is always less than the distance to travel between the two cities. Understood? The straight distance between the two cities is always less than the distance to travel between the two cities. So, we can say that the second column of the table indicates the distance, while the third column of the table indicates the displacement. Right. Now, I have given you two definitions for distance and displacement. It is better if you can take them down as you have got your writing books in your hand. The length of the rod between two cities is known as the distance, and the straight distance between two cities is known as the displacement, right. I have got another two diagrams to show you, right. Now, you can recall an instance of 100 meter and 400 meter running events in your school sport meet, right. In the first diagram, you are given the track of 100 meter running event. In the second picture, you are given the track of 400 meter running event. As both these events are short distance races, there are certain differences between these two races. Between these two races, there are differences. We will see the differences. Here are the differences. Then we can compare the 100 meter running event and 400 meter running event. Direction of motion. My dear children, please draw your attention towards the direction of the motion of the runner in 100 meter race. You can observe that the direction of the motion of 100 meter runner does not change. The direction does not change. But when we think about the direction of the runner of 400 meter race, it changes with the time. The direction changes with the time, right. So, that is about the direction. When we think about the total length of the path in 100 meter race, the total length is 100 meters. The total length is 100 meters. But when we think about 400 meter running events, the total length of the track is 400 meters. The most important part of this table is the third one, third row. Linear length between the point of start and end. It is emphasizing about the point of start and end. The linear length between the point of start and end in 100 meter running event is 100 meters. Then you can think about that. The runner has started his motion and he has finished his motion after 100 meters. So, the linear length in between the starting and end positions is 100 meters. But when we think about 400-meter running events, the runner has come back to his earlier position. I think you all can understand this, it is very, very important. The runner has come back to its earlier position. Then he has come to his initial position, then we can say that his displacement is 0. His displacement is 0. Once again you may have a problem how the displacement of the runner has become 0. We will see. You can observe that in 400-meter running event, the person or the runner has started his motion and he has finished the race at the point where he started. Then we can't say about a straight distance between the initial and final positions. Then we can say that the displacement of this running event is 0 meter. Then you can understand. Both distance and displacement are lengths. In science, we measure the lengths in millimeters, meters and kilometers. But the international unit of measuring length is meter. The symbol is simple m as given on the screen. So, to measure the distance and displacement also we use meter. The international unit of measuring both distance and displacement is meter. Right? You have to understand that both distance and displacement are lengths. We have to use meter for measuring distance and displacement. Right. Let us get another example. My dear children, I want you to explain more and more about distance and displacement because these theories are really new to you. Now, this is the first time you learn all these things. Then I think it is better to explain more and more about distance and displacement using number of examples, right? Here also I have given you a certain motion. The starting point is A, it is denoted by capital A, and the end position or the final position is B. The object has started the motion from A and ends the motion from B. Within these 2 points, this is the distance covered by the object, that is shown by blue color dotted line. The distance is shown by the dotted line shown in blue color, right? The distance is 150 meters. That means the length of the path covered by the object is 150 meters. But when we think about the initial and final positions of the object, that is 50 meters. Right? Then you can understand that the distance is 150 meters. That is the length of the rod. But the length between the initial and final positions is 50 meters. That is a straight length. Then that is the displacement. Then you can understand the dotted line shows you the distance while the straight line shows you the displacement. But when we indicate the displacement, you have to indicate the direction because we learnt that displacement is a vector quantity. It has a magnitude as well as it has a direction. The distance travelled from A to B or the total length of the route is 150 meters, right? You know that. The displacement from A to B or the linear length between initial and final position is 50 meters to southeast. That is very important. 50 meter to southeast, I have given you the direction, right? That is very important. Right. Let us see another example. Look at the picture given on the screen. You can see there is a house and there is a factory. The man is travelling from house to factory through a rod, along a rod, right? The length of the rod is 200 meters. And you can see that the straight length between the house and the factory is represented by that dotted line. That length is 120 meters. Right. Based on this, these two questions are asked. We will see the answers for the question. A route for a man to travel from his home to factory is shown above. I explained you. Find out the distance travelled by the man. What is the answer? Yes, you can check whether your answers are correct. Find out the distance travelled by the man means the length of the road, that is 200 meters. In the second question, you are asked to find out the displacement northeast of the man. What is the displacement of the man? The answer is, it is clear, the answer is 120 meters. The direction is given. Example number 2. Now you can see the second example. There is a house and a well nearby the house. The woman goes to the well to fetch water and she returns home along the same route. You can understand that the straight distance between the house and the well is 10 meters. That is the displacement between the house and the well. When the woman is going to the well, she is covering a distance of 15 meters, and when she returns home, she is covering another 15 meters distance. Then the whole distance covered by the woman is 15 meters plus 15 meters. It is similar to 30 meters, right? So by looking at this example, we can summarize about the motion of the woman in this way. From home to the well, you know the length of the path, that is 15 meters, and the displacement is 10 meters. From well to the home, she is coming back, she is returning to the home. Distance travelled is 15 meters and the displacement is constant. It does not change, that is 10 meters. Going from home to the well and returning, the whole motion of the woman, the distance travelled is 15 meters plus 15 meters. You have to add both, then it becomes 30 meters and the displacement has become 0. My dear children, then you will have a problem why the displacement has become 0. The reason is the woman has come to her initial position. Then we can't say about a straight distance between the first and last positions. Then we have to say that the displacement of the woman is 0. Right? Now I think you can understand about distance and displacement. Right. The second part of the lesson is based on force. Force. What do you know about force? Right? Have you heard about this word? Yes, I know that this word is familiar to you as you are learning science. Before talking about the force, I have got some examples to show you. These pictures are showing you different activities that are done in our daily life. We will see. Riding a bicycle, hitting a ball, pushing an object, lifting an object. Riding a bicycle, hitting a ball, pushing an object or lifting an object. Right. In addition to the answers that are given on the screen, there may be some other answers. We will see. We engage in various activities in our daily life. Then you can list out different activities that are done in your daily life in your notebooks. Here are my answers. Drawing water from a well, writing with a pen, brushing teeth, lifting objects, closing or opening a door. Right now, those are different types of activities that are done in our daily life. In all these activities, a push or a pull is applied. Then you can understand that in all these activities, there is a pushing or pulling. a push or a pull is applied during all these activities. In my next activity, then you must understand the difference between pushing and pulling, right? We will see. Select whether the action is a pull or a push. Now, I will give you some actions. You have to think whether these actions are pull or push. Action done is drawing water from a well. So, you have to think about an instance where you take water from a well. Is it a pulling or a pushing? Yes, that is a pull. Applying brakes of a vehicle, you know that the brake pedals are pushed by the leg, then that is a push. Hitting a ball, when you hit the ball, it is not a pulling, that is a pushing. Lifting a bag, the bag is pulled up. When you lift a bag, there is a pulling. Then you have to understand that all the activities done in our daily life can be a pull or a push. Through that, we can come to the force. We will see what the force is. Pulling or pushing is known as applying a force. We can simply say that force is a pulling or a pushing. The international unit of measuring force is Newton, that is symbolized by capital N. The international unit of measuring force is Newton, capital N. The equipment used to measure the force is Newton's spring balance. Have you seen Newton's spring balance? Yes, you may have seen and you may have used them, but I also have brought a Newton's spring balance to show you. Shall we observe? Okay. Here I have got a Newton spring balance. You can observe that the spring balanced is marked in Newton, right? This is a Newton spring balance. It is calibrated in newtons as well as in grams, right? There is a spring inside the balance. There is a spring, right? This is a Newton spring balance. I think you all have seen it and you all have used it in activities in science. Right, there are two activities. Before engaging the activities, I would like to explain you how to do the activity. Activity 1. Place a wooden block on a table and pull it using a spring balance. Right, you have to understand the first step is placing a wooden block on a table and pull it using a spring balance. Place another wooden block on the first block and pull again using the spring balance. Here we can use a similar wooden block to the earlier one. Place another wooden block on the first block and pull it again using the spring balance. Finally, record the readings of the Newton balance in both occasions. Record the readings of the Newton balance in both occasions. Shall we do the activity? Okay. My dear children, this is a wooden block. Then you can see that the spring balance is connected to the wooden block in this way. Now, I am going to pull the wooden block using the spring balance. Right. The wooden block is moving. Then you can observe that the reading is 0.5 Newton. The reading of the spring balance is 0.5 Newton. Now, I have got another wooden block. It is similar to the first block. Both wooden blocks are similar. Right. Now, I am going to keep the second block on the first block in this way. Now, I am going to apply the force using the spring balance. Now, you can see the reading of the spring balance has increased. The reading of the spring balance has increased. My dear children, you have to understand that when we use one wooden block there was a reading in the spring balance. But when we use both wooden blocks, the reading was increased. The reading was increased. Observation, activity 1. Now you have got the observation. We will see. The reading of the Newton balance at the second occasion is greater than the reading of the first occasion. Right? That was clear. The conclusion of activity 1. What is the conclusion we can at the end of the activity? That is, a greater force is applied at the second occasion as there were two wooden blocks used. Right? That was clear. When we use one wooden block, there was a reading in the spring balance. It was doubled or it was increased when using two wooden blocks. That was clear. That was the conclusion of the activity. Now we are going to move on to the second activity, activity 2. Let us go through the activity first. After that we can do the activity. Attach a Newton spring balance using a piece of thread to a wooden block kept on a smooth surface. The wooden block should be kept on a smooth surface, and then attach a Newton spring balance using a piece of thread. That is the first step of the activity. Pull the block using the Newton balance. The block is pulled using a Newton balance. Observe the direction of the motion of the wooden block. Right? That is the third step of the activity. Then push the wooden block and observe the direction of pushing and the motion of the object. Finally, we can remove the spring balance and then we can push the wooden block using our hand. Shall we do the activity? Okay. Right. My dear children, now I am going to pull the wooden block using the spring balance in this way. Now you can observe the wooden block is moving towards the direction of my pulling. Can you understand? The wooden block is moving along the direction of the thread, along the direction of my pulling. Right? You can understand. Now what I am going to do is removing the spring balance and it is kept away. Then I am going to push the wooden block using my hand. Right? The earlier activity was a pulling. Now I am pushing the wooden block. Now you can say that the wooden block is moving along the direction of my pushing. Right? By keeping that in your mind, we can come to the next part of the lesson. The wooden block moved to the direction of pulling and pushing. You could understand that. When the wooden block was pushed by my hand, that was moving to the direction of pushing. When the wooden block was pulled using the spring balance, the wooden block was moving along the direction of pulling. Then you have to understand that all the objects are moving to the direction of pushing or pulling. Simply we can say that the objects are moving to the direction of the given force. When we apply a force to an object, the object is moving according to the direction of the force. That is a very important theory related to science. The conclusion of the activity. The object moves to the direction of the force applied on it. The object moves to the direction of the force applied on it. That is very important. My dear children, we have done all the activities. Now you can understand the difference between distance and displacement. Then we were talking about force, pushing and pulling can be a force, right? A force has a magnitude and a definite direction. A force has various effects. you know that the quantities that have a magnitude and a definite direction are called as vector quantities. If the force has a magnitude and a definite direction, what kind of quantity is a force? Yes, very good. It is a vector quantity. Force is a vector quantity. And it has various effects. By applying a force, we can do different things. There are different results, so there are different effects of a force. We will see what are the different effects of a force. Various effects of a force. We will see. An object can be moved by applying a force. An object which is at rest can be moved by applying a force. A moving object can be stopped by applying a force. When there is a moving object, it can be stopped by applying a force. The speed of an object can be changed by applying a force. The speed of an object can be changed by applying a force. So, you can, if you want to increase or if you want to decrease by applying a force, you can do that. Direction of motion can be changed by applying a force. There is a direction of the motion. If you want to change the direction of the motion, it can be done by applying a force. Rotation or turning effect can be resulted by applying a force. I will be explaining you with examples how rotation or turning can be resulted by applying a force. The shape of an object can be changed by applying a force. The shape of an object can be changed by applying a force, right. Look at the pictures given on the screen. I think you can easily identify the pictures. The first picture is showing you how an arrow which is at rest is moved using a bow. An arrow at rest can be moved by applying a force to a bow. By applying a force to the bow, the arrow can be moved. In the second instance, there is a catapult. Have you got a catapult? Yes, you may have a catapult, but only to play, not to harm the animals. A stone at rest can be moved by applying a force to a catapult. By applying the force to the catapult, you can move a stone which is at rest. In the next picture, you can see there is a ball. By kicking the ball or by giving a force to the ball can be moved. A ball at rest can be moved by hitting with the leg. So, finally, we can say that living or non-living things at rest can be moved by applying a force, right. The objects that are not moving can be moved by applying a force, right. That is the first effect of the force. Look at the pictures given on the screen. The speed of a bicycle can be increased by increasing the force applied on the pedal. By increasing the force applied on the pedal, the speed of the bicycle can be increased. In the second picture, you can see the animals are running fast. The animal can change its speed of motion by changing the force applied onto its legs, right. The animal can change the speed by changing the force applied onto the limbs of the animals. You can see a vehicle which is moving along a road. The speed of the vehicle can be increased or it can be decreased by treading on the accelerator. The speed of an object can be changed by applying a force. That is the final thing, that is the final result of applying the force. The speed of the object can be changed. Right. Look at the instances given on the screen. In the first instance, you can see a cricketer. A cricketer is hitting a ball. The cricketer can change the direction of the ball by hitting it. Yes, he can change the direction of the ball. In the second picture, you can see a rope pulling. right? I think you have experiences of pulling ropes in New Year season. Each team tries to change the direction of the motion of the rope in pulling rope. When the rope is pulled, each team is trying to change the direction. So that is another effect of force. Direction of motion can be changed by applying a force. We can apply a force to change the direction of an object. Right. You can observe that the first one is a picture of a tap and second one is a steering wheel of a vehicle. When a force is applied, the tap turns. The tap turns when the force is applied, and when a force is applied, the steering wheel turns. I said you that there is a turning effect or rotation can be done by applying the forces. A rotation or a turning effect can be resulted by applying a force, right? A rotation or a turning effect can be resulted by applying a force. Right. Look at the first picture, right? Can you do that? No, you can't do it, but you may have seen it in displays. Bend in iron bars and taking different shapes using clay. Right, now you can see by applying a force, the shape of the object has been changed. Right, in the first picture you can see this person is applying a force, then he can bend the iron bar. He can change the shape of the iron bar. In the second picture, we can get different shapes from the clay by giving a force. In this picture, you can see how to press a plastic bottle by applying a force. Pressing a plastic material to change the shape. The shape of the plastic bottle can be changed temporarily by applying a force. The shape of an object can be changed by applying a force. Right. My dear children, now I have explained you about distance and displacement, vector quantities and scalar quantities, the force and different effects of the force. I think it is better to explain you a little about gravitational force because it is very important theory related to physics. What is known as gravitational force? A force is exerted by the center of the earth on all objects on the earth. When we think about the objects that are on the earth, all the objects are attracted towards the center of the earth. A force is exerted by the center of the earth on all objects on the earth. This force is called gravitational force. This force is called as a gravitational force, right? You have to understand it. What is the difference between the weight and the mass of an object? My dear children, we think that both mass and weight are same. But in science, the mass and the weight are different. In science, the mass and the weight are different. There is a difference between mass and weight. We will see. The gravitational force exerted on an object is the weight of an object. The gravitational force exerted on an object is the weight of an object. The weight is a force that is measured in newtons as it is a force. But when we think about the mass, that is not measured in newtons because that is not a force. The mass is the amount of matter containing in an object. The mass is the amount of matter containing in an object that is measured in kilograms, grams or milligrams. So, the international unit of measuring mass is kilograms, right. Now, there is a difference between weight and the mass. Okay, my dear children. Now, I have explained you all the important parts of the lesson related to this topic. Now, I am going to sum up the lesson in this way. Let us take a short summary of the lesson. The total length of the motion of an object is called distance. Once again, I would like to recall what we have learned about the distance. We learned that the distance is the length of the path of the motion of an object that was measured in meters. the total length of the motion of an object is called distance. Then when we think about the displacement, the straight distance, the straight length between the starting and end points of the motion of an object is the displacement, right. Once again I would like to recall what you learnt about the displacement. The straight length between the starting and ending points of the motion of an object is called the displacement. Then we learnt that both distance and displacement can be measured in meters, that is the international unit of measuring distance and displacement. A push or a pull is called as a force. Then we were talking about force. Force can be a pushing as well as it can be a pulling. Then we did two activities. I think you can remember how we did the activities, how we got the observation and how we came to the conclusion of those activities. A pushing or a pulling can be a force. By applying different forces, we can do different activities. There are different effects of forces or there are different results of forces. I think you all can remember what are the different effects of the force. By we can change the direction of the motion, we can change the shape of the objects, then we can move the objects that are at rest by applying a force. Right, now those are the things we discussed under the topic of force. Then we were talking about the international unit of measuring the force, that was Newton. Then I explained you how to use a Newton spring balance and I showed you the Newton spring balance. Then Newton is denoted by capital N. When you are using Newton, when you are writing Newton, you have to use capital N. And a force has various effects, right? I explained you them earlier. At the end of the lesson, I want to assess whether you learned what I taught you. You can do these assignments. I know that these days you are freely spending your time, then you have more time to engage in assignments. Then you can complete these assignments in your writing book. We will see the assignments. Assignment number 1. Prepare a list of uses that you get by applying forces in your day-to-day life. Prepare a list of uses that you get by applying forces in your day-to-day life. My dear children, you can think about the instances where you apply forces in our day-to-day life, and then you can prepare a list of the instances where you apply the forces. Then you can write them in your writing book. Look at the second assignment. Collect pictures and diagrams of instances of applying forces in day-to-day life and paste them in your writing book. Once again, let's read the question. Collect pictures and diagrams of instances of applying forces in day-to-day life and paste them in your writing book. So then you can refer the books, newspapers, and then you can use various materials and then you can collect pictures of forces where we apply the forces in our daily life. Then not only pictures, you can collect the diagrams also, and then you can cut them off and you can paste them in your writing book to make a nice collection of pictures. I am sure that you will be doing all these assignments. My dear children, today I explained you force and motion, that was unit 16 of your textbook. I am sure that you enjoyed today's lesson. Until I meet you with another interesting science lesson, stay safe and goodbye.